Good morning, dear students. Today we are going to continue with the further part of the lesson HCF and LCM. That is, we are going to start with practice set 13. So the first question in practice set 13 is, find the LCM. And the first question which I have selected, that is 12 and 15. So now let's learn how to find the LCM of the numbers 12 and 15. For that, first we have to write these numbers. Okay. Now we are going to use the prime factor method to find out its LCM. So let's start with the first prime number, that is 2. If you will look at the units place of these two numbers, we have 2 and 5. 2 is divisible by 2, but 5 is not divisible by 2. Therefore, these both numbers are not divisible by 2. Now we'll move on to the next prime number, that is 3. As we all know the 3's table, we can, by looking at the numbers only, we can tell that 12 and 15 are divisible by 3. Means both of them come in 3's table. So students, we are going to write here the number, that is 3. 3 4s are 12 and 3 5s are 15. Now the numbers obtained by us are 4 and 5. 4 is further divisible by the prime numbers. Yes, but 5 itself is a prime number. So 4 still we have to convert to a prime number. Then 4 is divisible by 2, which is our first prime number. Yes or no? But 5 is not divisible. But what we have to do here, we have to do this factorization till we get all prime numbers in this last row. Okay. So we will find the factors of 4. The prime factors of 4 are 2, 2's are 4. But 5 is not divisible by this 2. So we are going to write this 5 as it is. Now if you will see, the numbers obtained are 2 and 5. Both of them are prime numbers. They are divisible by their own table and by 1. And as both of them come in 1's table, we have to stop here. That means we have found out the LCM now. So what is the LCM of these numbers 12 and 15? The numbers in this first column and last row are the factors for the LCM. So we will write here LCM is equals to 3 by 2 multiply by 2 multiply by 5. So 3 2's is 6, 2 5's are 10 and 6 10's are 60. Therefore, 60 is the LCM of 12 and 15. Now let us solve the next sum, 105 and 195. Okay. So I have written those two numbers here. Now if you will see at the units place of these numbers, then we have 5 and here also we have 5. This tells us that it is not divisible by a first prime number, that is 2. So now we'll check whether they are divisible by our next prime number, that is 3. Goes sequence wise. How the prime numbers list you have, like that you go on finding. You will surely get the answer. 5 plus 0, 5. 5 plus 1, 6. So addition of this number is 6. That means this number will be divisible by 3 because 6 is divisible by 3. Now we will check whether this number is divisible by 3 or no. 9 plus 1, 10. 10 plus 5, 15. 15 is divisible by 3. That means 195 is also divisible by 3. So we are going to write here first number for test of divisibility, that is 3. Now 3's table you will not have 1. Then we'll check for these two digits 1 and 0, that is 10. Will you have 10 in 3's table? No. But smaller number? Yes. What is that smaller number? 3 3's are 9. 1 is remaining, give here, it becomes 15. 3 5's are 15. Now next, 1 is again not divisible by 3. You will check two numbers, that is 19. 19 is not divisible but smaller number than 19 is divisible by 3. What is that smaller number? Yes, 3 6 are 18. 1 is remaining, write it here. Again we have 15, that is 3 5s are 15. So the new numbers what are obtained are 35 and 65. Now see students, 105 and 195. Both these numbers are divisible by 3. Okay. Both of them are divisible. Now we will check whether 35 and 65 are divisible by one number, any one number or no. They are not divisible by 2 because at units place we have 5. Now just add the digit of first number. 5 plus 3, 8. 8 is not divisible by 3, means 35 is not divisible by 3. 5 plus 6, 11. 11 is not divisible by 3, means 65 is also not divisible by 3. Next prime number is 5. If you will look at units place of this number, you have 5. That means both the numbers are divisible by 5. 5 how much are? Correct. You can directly tell here 5 7s are 35 and 5 13s are 65. Yes. Now you have got the numbers 7 and 13. Both these numbers 7 and 13, are they prime numbers? Yes, so we have to stop here. Because both are divisible by their own table and by 1. And as they are divisible by only 1, we have to stop. Means we have got our LCM. So what is our LCM? I'll write it down. LCM is equals to what? See the numbers from the first row. What are the first column? What are those? 3 and 5. And last row 7 and 13. So LCM will be 3 multiplied by 5 multiplied by 7 multiplied by 13. Yes. Now we have to carry out multiplication of these numbers. 3 5s are correct 15. Is it? So we will just write it here. 3 5s are 15. Yeah. Next 13 7s is how much? Correct. 13 7s is 91. So we'll write here 91. Now if you will multiply these both numbers in the rough work, you will get the answer 1365. You can do this multiplication in rough work. Yes. So the LCM of both this number is 1365. Okay. So now what you are going to do, students? In your CW, you are going to write down these two sums in neat and good handwriting. You have to write practice set 13, question 1 and solve these two sums. So students, whenever you are finding LCM of any number, you also get HCF in that. Shall I show you how? Now just see the first sum, 12 and 15. Both were divisible by 3. Yes. So 3 is a common factor of both of them. Then we got the answer 4 and 5. Here 2 is divisible only by 4, not by 5. Yes. So the common factor in both the numbers is 3. So HCF is 3. We have already learned what is HCF. HCF means that numbers are divisible by all the given numbers. So here 3 is divisible by both the numbers. Yes. In the same way, students, in this sum 105 and 195, both of these numbers are divisible by 3. And we get the answer 35 and 65. Then 35 and 65, both of them are divisible by 5. So the HCF in this sum will be 3 and 5. 3 multiplied by 5 will give us 15. So students, whenever you are solving the sums of LCM, in that you have the HCF also. So always remember the numbers which are divisible by both the given numbers or by the given numbers, that numbers are the HCF. Yes. So 3 was divisible by both of them. 5 was divisible by both these numbers. So 3 and 5, if you will multiply, you will get 15. And 15 is the HCF in this sum. Okay. And now, if you want to find LCM, then you will see the common numbers, that is 3 and 5, and 7 and 13, the uncommon numbers. All of them when you will multiply, you will get answer 1365. Then 1365 is the LCM of the given numbers. Did you understand? So whenever you are finding the LCM of any number, you can get HCF also. Okay. Let us now solve the next sum, that is 45 and 86. We have to find LCM of these two numbers. Now just see at the units place, we have 5 and 6. This tells us that 45 is not divisible by 2, but 86 is divisible by 2. We will first see whether these two numbers are divisible by one single number or no. If not, then we will divide it by one single number. Separate. Okay. Now just see. These both are not divisible by 2. Let's move on to the next prime number 3. Add the digit. 5 plus 4, 9. 8 plus 6, 14. 9 is divisible by 3, but 14 is not divisible by 3. So both these numbers are not divisible by 3. Now next number is 5. Are they divisible by 5? Yes, 45 is divisible by 5, but 86 is not divisible by 5. Then the next number will be 7. Are these two numbers divisible by 7? No, they are not divisible by 7. See students, both these numbers are not divisible by one single number. Yes. So first what we are going to do? First we will use the prime number 2, and that 2 is divisible by 86. Is it? So first we will use 2 here, and we will write here 2 4s are 8, 2 3s are 6. Now we have got 43 as a new number. 45 is not divisible by 2, so we will write it as it is, that is 45. Now if you will see, 43 is a prime number which is divisible by 1 and by its that same number. Yeah, so we will keep it as it is. Now we'll just look at the other number, that is 45. 45, if you will add this digits from this number, they will be 4 plus 5, that is 9. 9 is divisible by the prime number 3, and thus 45 is also divisible by 3. So we will write here 3 ones are 3. From 4, if we subtract 3, 1 will remain. That 1 we will write near 5 like this, and we can get this 15 in 3's table. 3 5s are 15. 43 is not divisible, so we will write that 43 as it is. Now again 15 is divisible by 3, that is 3 5s are 15. Yes, 43 is prime number, so we will write it again as it is. Now if you will see the last rows, two numbers are 5 and 43, which are prime numbers. Yes, so we have to stop here. On table or by 1. So we have to stop here. See students, in this sum we have just got the LCM. We will write it down because they have asked us the LCM. So the numbers in the first column and the last row we are going to write and multiply them. So they are 2 multiplied by 3 multiplied by 3 multiplied by 5 multiplied by 43. Okay. So now if you will see these factors, you have to multiply them. 2 3s are 6. 6 3s are 18. Yes or no? And 18 5s is correct. 18 5s is 90. So you'll write here 90 multiplied by 43. Okay. Now just do the multiplication. 9 3s are 27. 2 we will write here. 9 4s are 36 plus 2 38 and 0. So our multiplication has given us answer 3870. Therefore LCM of these two numbers is equals to 3870. Did you all understand how to find the LCM of the two given numbers? It's very easy. Okay, what you have to do, first you have to check whether the two numbers are divisible by one common table or no. If they are divisible, you have to divide it. If not, then you have to divide like this separately. 45 was not divisible by 2. 86 was divisible. So first you divided 86 and wrote 45 as it is. Then 43 was not divisible by 3. 45 was divisible. So you divided it. You got answer 15 and you wrote 43 as it is. Then 15 was divisible by 3, so you divided it. 3 5s are 15. 43 was not, so you wrote it as it is. So the numbers obtained in the first column and the last row was the LCM. When you multiplied it, you got the multiplication answer. That was the LCM of the two given numbers. In this sum, we didn't have HCF. We didn't get HCF. That means HCF is 1. Okay. Now let's move on to the further sum. So now let us solve the next sum. The question is we have to find the LCM of 10, 15 and 20. So now we will check whether all these three numbers are divisible by our first prime number, that is 2. If you will see students, then 10 and 20 is divisible by 2. 15 is not divisible by 2. Okay. So we will not use 2 here. We will move further. Next prime number is 3. 3 is divisible only by 15. 10 and 20 are not divisible by 3. So we will move to next prime number. What is our next prime number? 5. And if you will see, then 5 is divisible by all these three numbers. Yes or no? So we will use here 5. Otherwise we would have moved to the next prime number, or we would have solved each one separately like this third sum. But what has happened here? All these three numbers are divisible by 5. So we have to write here first prime number, that is 5. So 5 2s are 10, 5 3s are 15, 5 4s are 20. All of them are divisible. So we have written, as all of them are divisible, can we say 5 is their HCF? Yes, we can say, because all these three numbers were divisible by 5. Now we will move further because we have to find LCM. So the numbers obtained now are 2, 3, 4. Now 2 and 4, are they divisible by 2? Yes. But 3 is not divisible. Yes or no? So what we will do? We will keep 3 as it is, and now we will just divide other two numbers and take. So see here. Now we will use test of divisibility of 2 and write here 2 1s are 2, 2 2s are 4. And 3 is not divisible, so we will write it down as it is. Now at the last row we have got the numbers 1, 3 and 2. 3 and 2 both are prime numbers, so we have to stop now. That means we have got our LCM. So what is our LCM? Yes, again the numbers from first column and last row will be our LCM. We'll write it down. LCM is equals to 5 multiplied by 2 multiplied by 1 multiplied by 3 multiplied by 2. 5 2s are 10. So we'll write here 10 1s are 10. 3 2s are 6. And 10 6s are 60. Therefore, LCM of these three given numbers is 60. I hope you have understood how to solve this sum. Yes or no? Here 5, if anybody asked, what is the HCF in this? The HCF in this sum was 5, because all these three given numbers were only divisible by 5. Yeah, and then further we have found the LCM. So in every sum you can have the HCF. In some sums you don't have the HCF, like this third one. But in many of the sums you will get the HCF also in LCM. So now let us begin with the fifth sum. I have selected the numbers 12, 15 and 45. So now we will find out its LCM. First we are going to see whether all these three numbers are divisible by one single table or no. So we can use test of divisibility of 3 here. 2 we cannot use because 5 are there at units place here. So 2 is not possible. 3 is possible because 12, 15 and 45 all are divisible by 3. 12 and 15 comes. 5 plus 4 is 9, means this 45 will also come in 3's table. So students, we are going to write here 3 4s are 12, 3 5s are 15 and 3 13 3 15s are 45. Yes or no? So, after this, we are getting the new numbers. They are 4, 5 and 15. Now, are all these three numbers divisible by one table? No. These 5 and 15 are divisible by 5. Yes or no? And 4 is divisible by 2. Now we will solve them separately. Yeah? See how to solve. 4 is divisible by 2. So we will write 2 2s are 4. 5 and 15 are not divisible. So we will write them as it is. Now we have the numbers 2, 5 and 15. 2 is not divisible by 5. But other two numbers are divisible. So we'll write here now next prime number 5. 1s are 5. 5 3s are 15. As 2 is not divisible, we will write it as it is. Now if you will see in the last row, we are getting 2, 3, which are prime numbers. So we have to stop here. Thus we have got the LCM. LCM is equals to 3 into 2 into 5 into 2 into 1 into 3. Okay. If you don't write this 1, then 2 it's okay. So no need to write 1. We will just write directly 3. So now multiply 3 2s are 6. 6 5s are 30. 2 3s are 6. 3 6s are 18 and 0 will give us 180. So the LCM of this 12, 15 and 45 is 180. Yes or no? So we'll write here the last statement, that is therefore LCM is equals to 180. In this sum we have HCF also. Can anybody tell me what will be the HCF in this sum? Yes, the HCF is 3 because all these three numbers were divisible by 3. Further, the three numbers were not divisible by any other number, that is 2 or nothing. 2 was divisible by 4. These remaining 2 were not divisible by it. So only these first three numbers were divisible by. Let us now begin with the sixth sum, 18, 36 and 27. So I have written here the same numbers. So all these three numbers are divisible by 3. Yes or no? All the numbers are not divisible by 2. First two are divisible by 2. Third one is not divisible by 2. So next prime number 3. 18, 27 is there in 3's table. Yes, and even 36 is there because 6 plus 3 is 9. If 9 is divisible by 3, means 36 also is divisible by 3. This tells us that all the three given numbers are divisible by 3. So we will write the first prime number, that is 3, which can also be the HCF because all three numbers are divisible by 3. 3 6 are 18, 3 12s are 36 and 3 9s are 27. Yes students, did you understand? 3 6 are 18, 3 12s are 36, 3 9s are 27. Now the new numbers obtained are 6, 12 and 9. If you will see, then again all these numbers are divisible by 3. So now we can again write 3 here. Means this 3 will also be our HCF. Yes or no? Means both these three are our HCF because all the three given numbers are divisible by them. Now you will see all this green 6, 12 and 9. They are also divisible by 3. How? 3 2s are 6, 3 4s are 12, 3 3s are 9. So here both these 3 in the first column are our HCF. Now move further. What new numbers we got? The new numbers obtained are 2, 4 and 3. So now 2 and 4, are they further divisible by 2? Yes, but 3 is not divisible. Yes. So first these two numbers we will divide and take. 3 is a prime number. So we will keep it as it is. Okay. Now see here 2 1s are 2, 2 2s are 4 and 3 we will write as it is. Now the numbers obtained in the last row are 1, 2 and 3. 2 and 3 are prime numbers, so we have to stop here. Thus, we have got the LCM. LCM is equals to 3 into 3 into 2 into 2 into 3. No need to write 1. 3 3s are 9. 9 2s are 18. 2 3s are 6. So, we are going to write here 6. Okay. Now, 18 6 is how much? Correct. 18 6 is 108. Therefore, the LCM of the given number is 108. So students, from practice set 13 question 1, I have solved 6 sums. What you are going to do in your CW, you are going to write all these 6 sums and then you are going to search which 4 sums are remaining and that 4 sums you are going to continue after this 6 sums. And in this way, you will complete all the 10 sums from question 1 of practice set 13. In the next video, let us study question number 2 of practice set 13.